Good morning, Honorable Prasan here. Now we are going to talk about the computer architecture. So, first of all, we are going to discuss about the unit number 1. So, what is the unit number 1 means? Is first topic of the unit number 1 is the functional units of the computer. First of all, what is a computer? Computer is an electronic device for storing and processing data. It's a binary form according to the instruction given to in a variable program. So it is a computer is an electronic device. We are storing the data, also storing according to the instruction. We are going to store the data. What is architecture? Architecture is a specification detailing how a set of software and hardware technically standard interact to form a computer system or platform. The functional units. So the first topic of the unit 1 is the functional units. The functional unit is a 5 major function. One is a input, second one is a input device, second is a storage area, third one is a processing area, fourth is a control, fifth one is the output area. The input means we are fetching the instruction to the CPU. The CPU is contain arithmetic and logical unit, its control unit and memory unit. The finally we are the central unit. It finally gives the output. The whole this process is called as a functional unit of the computer architecture. The input, we know the input devices that are attached to the computer. These devices take the input and convert into binary language that the computer understands. Some of the common input devices are keyboard, mouse, joystick, scanner and etc. The central processing unit, we are going to processing some information and data. This is a very important part of the device of the computer architecture. So we know the ALU, this is arithmetic and logical unit. We are going to perform addition, subtraction and multiplication, division operations also. So next one is the control unit. It is used to control the operations of the computer architecture, and also it is control all the devices and control the arithmetic and logical devices. Next thing is the memory. Memory is attached to the CPU, is used for storage of data and instruction and is called internal memory. The internal memory is divided into many storage locations, each of which can store data instructions. So each memory location is of the same size and has address. With the help of the address, the computer can ready and memory location easily without having to search the entire memory. We have primary memory and secondary memory, and RAM means random access memory. Both read and write operation is possible for this random access memory. The next one is called as output unit. The output unit, we know the output devices. Is a monitor is one of the example of the output devices. Output unit consists of output devices that are attached with the computer. It converts the binary data coming from CPU to human understandable form. The common output devices are monitor, printer and plotter, etc. This is a device. This is a CPU. We are containing power supply and processor and memory stick and video card and motherboard and hard disk. This is the internal architecture diagram of diagrammatic view of this diagram. So another one diagram, we are the peripheral devices. We are including these peripheral devices in functional units. This is called as basic computer architecture. First of all, what is meant by computer architecture, and what is meant by computer? Computer is an electronic device for storing and processing data in a binary form according to instruction given to it in a variable program. What is architecture? We are going to build the computer. How we are going to build the computer? It is computer architecture is a specification detailing how a set of software and hardware technology standards interact to form a computer system or platform. So this is called as computer architecture. We are build the software using a hardware. Also, first topic of the unit number 1 is a functional unit. We know the 5 major roles of input unit, arithmetic and logical unit, control unit and memory unit and output unit. So these are the 5 units of the device. The next one is called as basic operational units. This is the diagram for basic operational unit. So first one is the memory, is the storage area. We are storing all the instruction in memory. So first of all, MER is a memory location register, memory address register, and memory data registers. PC is the program counter. It fetches the next instruction to be fetched and executed. Information register, IR is instruction register. That is currently it's called the current instruction to be executed using the general purpose registers. And also MAR is the memory address registers, MDR memory data registers. ALU we using for arithmetic and logical operations are performed in ALU: addition, subtraction, and multiplication, divisions. These are the steps to execute the instructions. Okay, we know that opcode and operands. Okay, so this is the diagram of basic operational concepts of this diagram. So this is example of location A, R1, add R1, R0. There are the following steps to be execute the instruction. Step 1, fetch the instruction from main memory into processor. Fetch the operand to location A from main memory into register R1. Add the content to R1 and content of register R0. Store the result to R0. So this is the basic operational concept of the computer architecture. Next one is the bus structures and performance matrices. Bus structure and performance matrices. A bus is a collection of wires that contains several devices. Bus, we know we are going to connect to one place to another one place, that is called as bus. This is the general meaning. So in this place we are going to connect the signals we are going to transfer the signals from one place to another place, transfer the data to one place to another place, transfer the address to one place to another place. Bus is a collection of wires that contain several devices. Buses are used to send the signals and data between the processor and the other components. This is to achieve a responsible speed of the operation. In a computer, all peripherals are connected to microprocessor through the bus. There are 3 buses: address bus, data bus, and control bus. The name itself, we know the address bus, it contains the address only. The data bus, it contains carry the data only. The control bus will carry the control signals only. So this is the general diagram of computer buses architecture. The CPU, memory, and input output is 3 devices, input and output. We are using the 3 areas. We are going to connect the buses. So unidirectional and bidirectional buses we are using. The whole 3 buses are control bus and data bus and address bus. 3 buses is called as system bus. System bus means we are combined all the buses. Address bus is used to carry the address. It is a unidirectional. It is a single directional. So that is a single directional one. It's not the bidirectional. That's only we are transferring. We are sending the address only for this bus. Data bus is used to transfer the data to form memory and IO devices. It's a bidirectional one. So both the direction it's going to be sent. It's a bidirectional one. Processor can read the data lines from memory and IO port, as well as it can write the data to memory. Next one is a control bus is used to carry the control signals in order to regulate the control activities. They are bidirectional one. Both the side we are transferring the data. CPU send the control signals on control bus to enable the output address to the memory devices or port devices. So this is the diagram of computer buses. Okay, next one we go for that is performance and matrices. Performance and matrices, how we are going to check the performance and matrices. So we are going to check the performance of the system. How we are going to run the system, how we are going to calculate the execution time of the system. There are 3 major criteria for finding out the performance. This one is a response time, another is a throughput, another one is a execution time. Response time is the time from start completion of task. Throughput is the total amount of work done in a given time. CPU execution time is a total time of a CPU spent computing on given task. It's also executed time for IO or running other programs. This is also referred as simply CPU time. This is the formula. Performance equals 1 divided by execution time, and performance A greater than performance B. 1 divided by execution time A greater than 1 divided by execution time B. Execution time B greater than execution time A. So if given that a processor A is faster than processor B, that means of execution time A is less than that execution time B. Therefore, the performance A is greater than performance B. Performance A divided by performance B equal to execution time of B divided by execution time of A. Performance A divided by performance B, execution time B divided by execution A equal to 1. An example, if a computer runs a program 10 seconds and computer B runs the same program 20 seconds, how much faster A than B? Speed up of A over B 20 divided by 10 2, indicating A is 2 times faster than B. A is 2 times faster than B. Second, we go for calculate execution time of CPU. The time to execute given program can be computed. The execution time equal to CPU clock cycle into clock cycle time. Execution time equal to CPU clock cycle divided by clock rate. CPU clock cycle, number of instructions for a program into clock cycle per instruction. Instruction count into CPU execute clock cycle per instructions. Basic performance equations. T equal to CPU time equal to instruction count into CPI divided by clock rate. T equal to N into CPI divided by R. This is the basic performance equations. This is a one simple example problem. So all of you know this problem. Next topic is instruction and instruction sequencing. Instruction and instruction sequencing. First of all, the first topic of unit 1 is functional. First of all, what is meant by computer? So first of all, what is meant by computer? What is computer architecture? Second thing, we go for the functional unit. Third, we go for the basic operational concepts. And fourth, we go for the basic structures and performance. Fifth, we go for the topic is performance matrices. We are using some formulas. Response time, throughput, and execution time is three major criteria. For the next one is next topic is instruction and instruction sequencing. Instructions are a set of machine language. The instruction that a particular processor understands and executes. Instructions are a set of machine language. Instruction that a particular processor understand and execute. Okay, it depends upon the processor we are executing the instruction. Some processor we are not understand our instruction. So in this place we are going to use for the decoding. Decoding means depends upon the processor we are going to convert the language, convert the machine language. Okay, we are using these three. One is a mode, another one is opcode and operand. Operation code is called as opcode field. Opcode field. Next one is the address field. It is a find out the location. The third thing is a mode field. It specifies how the operand will be located. How the operand will be located. So next we going to see for instruction life cycle. The instruction is a part of the program stored inside the memory. Each and every time we are going to recur the instruction. We are trying the instruction from memory. First we fetch the instruction from the memory, then decode the instruction and execute the instruction. Why we go for the decode the instruction? Why we go for the fetch the memory? Means just first we are store the instruction in memory. After that we are going to retrieve the instruction. That retrieving instruction is not suitable for our current processor execution. So we are going to decode that, depends upon the processor. We are going to decode. After that only we are going to execute. The whole this process is called as instruction cycle. Whole this process is known as instruction cycle. Add R1, R2, R3 using the three registers. Okay, so next we go for the four types of instruction. So one is a data transfer. Four types of operations in instructions. First one is a data transfer between the memory and registers. We using the move, push and pop operation. Data transfer between the memory and registers. Arithmetic and logical operation. Addition, subtraction, multiplication, division and or not. These are arithmetic and logic operations. Next one is a programming and sequencing control. Programming and sequencing control. Fourth one is I/O transfers. It's a in and out operations. In and out operations is possible. This is a register transfer notation, the explanations. Assembly language notation explanations. There are basic instruction types. Basic instruction types. These basic instruction types. Basic instruction types is we know that basic instruction types. So we have there are three address types. Opcode is add is a opcode. Source is a, the second source is a B, destination is C. Two address is opcode, source, destination. Opcode is A, source is A, destination is B. One address opcode source and destination load A is add B, store C, one address. Zero address, it is a push operation. It is a push operation. Next we move for next slide. So this is the instruction and straight line sequencing. Instruction execution and straight line sequencing. Instruction, we are going to execute the instruction different manner. It is the first one is straight line sequencing. The straight line sequencing means we are going to execute the programs in straight line manner. It's one by one manner. It is called as straight line sequencing. We are executing the instruction is one by one. So we are not, there is no chance for branching. Why we don't go for the branching means we are already executing in sequential manner, so there is no need for branching. But sometimes the sequential is not suitable for some execution, so if we want to go for the branching means we are going to execute the program in first line to fourth line, fourth line to fifth line, fifth line to eighth line, using the different steps in for branching. So next is straight line sequencing. Example is add A comma B comma C. First we complete the add, second we complete the B, finally we complete the C. Sequentially we are going to execute. But in branching is not suitable for this. In this branching we are going to use for different operations. This is a diagram for sequential. So move A comma R naught, add B comma R naught, move R naught comma C. 3 instruction program segment, data for the program. The next thing we go for branching instruction is using for, we are going to first line to fifth line we are going to jump. It is an unconditional call and return. There are three possibilities for branching. One is a jump, first line into fifth line we are going to jump, and is call first line into we are going to call the third line. Return means fifth, we are in fifth position, we are going to for the first position, that is called as return. These are the possibilities for branching. Sometimes the branching also not suitable, so sometimes both the operation sequential and branching we are going to use. The next one is called as jump instruction. This is the format of jump. Okay, the jump instruction transfer the program sequence to memory address given in the operand based on the specified flag. Call instruction, it transfer the program sequence to memory address given in the operand before transferring an address of the next instruction after call is pushed onto the stack. This is return instruction. The return instruction transfer the program from the subroutine to the calling the programs. Okay, this is the example of branch instruction. How we are going to use for branch instruction. This is the example. So next one is condition codes. Next thing we go for hardware and software interface. What is meant by hardware? Name itself, we know hardware is a collection of physical elements that comprise a computer system. Examples: processor, memory, hard disk and floppy disk, keyboard and mouse, monitors and printers. Software is a computer software or just software is a collection of computer programs that related data provides that instruction for telling a computer what to do and how to do. Okay, this is hardware and software. This is the peripheral devices of hardware. So first we use it for system fan, floppy, hard disk, hard drive, optical disk, RAM, processor, motherboard and power supply. So next we go for this. So different types of software: Windows OS, Linux OS and Java and Mac OS. There are different types of software we are using. This is the There are different types of software. One is a system software, another one is application software, another one is a programming software. System software, these software programs are designed to run your computers, application programs and hardware. System software coordinate the activities and functions of the hardware and software. Example, device driver. A software driver is a computer program allowing the higher level computer programs to interact with a hardware device. Operating system. An operating system is a set of programs that manage the computer hardware resources and provide common services for application software. Servers. A server is a computer program running to serve and request for other programs. The next one is called as programming software. It's only used to run the programs only, not only for. So this is used to software programming tool enable the developers to develop and write and test and debug the software programs, include assemblers, compilers, debuggers and interpreters. Application software used to many applications. User can use these applications. Okay, this is called as application software. The end user is the person who is actually using product or programs. So this is called as application softwares. The next one is called as business software. Another one is educational software, image editing software, industrial automation and mathematical software, spreadsheet and word processing. These are the different types of business area we using most of the Tally and this type of software. The educational software we using some portals, image Photoshop and photography areas, industrial automations. And mathematical we are going to solve the spreadsheet. We know the Google spreadsheet and WordPress also we know. So this is the next one is called as how we are going to interface, how we are going to communicate with the systems. So we are going to hardware interface, software interface, user interface. Hardware interface means the hardware devices are connected one to one. Hardware devices are connected one to one. All the devices are connected through the buses. So next one is called as software interface. Is programming interface or languages, codes and images that program to use communicate with each others and to the hardwares. Example, Windows, Mac, Linux operating system. The third thing is a user interface. The user interface is the point of the human computer interaction and communication in a device, including screens and keyboards. Okay, so this is the interfacing device. So again, first of all, again we will go for the all the topics. One time we are going to review all the topics. So first of all, what is computer? So computer electronic device, it is processing the data. It's a binary form. Computer architecture, we are going to build the software. How we are build the computer, we using the software and hardware. This is functional units. 5 major function: input and stored and processing and control and output unit. Third one is this input and central processing unit. So this is arithmetic and logical unit and control unit. This is memory, primary memory, secondary memory, RAM, ROM is possible. Output keyboard, output is a monitor, printer and plotters we using. This is a diagrammatic view of this diagram. This is also diagrammatic view. So third topic of unit number 2, one is called as basic operational unit. This is the diagram. Memory, MAR and MDR, PC and IR, program counter instruction registers are using. These are explanation steps. So these are the some opcode and operands are using. Buses, structures. Bus means bus is a collection of wires and connect the several devices. Data bus, address bus and control bus. This is the diagram of CPU, memory, control bus, data bus and address bus. The whole system is called as system bus. These are the explanations of each and every buses. This is performances matrices. We are going to check the performance of the system. We are going to check the response time and throughput and execution time of the system. These are the 3 major criteria. This is the formulas of performance and matrices. And also some simple problem is there. We are solved this problem. This is a common performance equation. T equal to N into CPI divided by N. CPU time divided by instruction count into clock cycle per instruction divided by clock rate. So this is the example problems. This is instruction and instruction sequence. We using what is by instruction? Instructions are a set of machine language Instruction that a particular processor understands and executes. This is instruction life cycles. What is instruction life cycle? So this is 4 types of operation: data transfer between the memory and registers, arithmetic and logical operations, programming, sequencing and controls, and I/O transfers. So this is register transfer notation. This is assembly language notation. This is there are different types of 3 addresses: 3 address, 2 address, 1 address, 0 address operations. The another thing is called as instruction execution and straight line sequencing. So what is meant by straight line sequencing? We are going to sequentially one by one we are going to execute. That is called as sequential execution. The another thing is called as branching. Branching means jump, call, return is possible for jump. This is the diagram of sequential. This is a branching. So jump, call, return is a branching example. So this is a jump instruction diagram. Another one is called as call instruction. The return instruction is also diagram. This is the example for all these things. Next we move for this hardware and software interface. How we are going to interface the hardware, how we are going to interface the software. Okay, we providing different instructions. Collection of physical elements is called as hardware. Collection of programs is called as software. This is the peripheral devices. Different types of operating system we using. There are different types of software. Software, it is used to run the system only. It's a default one. No one is change this software. Application software depends upon the user need. We are going to download the applications and we are going to store the application in the system. Programming software is only for developing and creating the programs in the programming tools, not only for using for program only we are going to, and also testing operations also possible for programming software. Okay, where these are the places we are going to use for business software, educational software, image editing and industrial automation, mathematical software, spreadsheets and WordPress. So another thing is interfaces. There are different types of interfaces. Interaction or communication between the computer and another entity such as printer, another computer network area and human users. Devices such as cable network, monitor and keyboard enable the interaction or communication between computer and other entity. Hardware interface, software interface and user interface. Hardware interface, the hardware devices we are going to connect with the buses and storage devices and I/O devices. Software interface, the languages, codes and messages that programs use to communicate with each other hardwares. User interface, the point of human computer interaction and communication in a device. This is called as user interface. Okay, so these are the some basic operations of computer architecture. Thank you. We will meet the next class. Thank you. Thank you, Anadol.